let's go to this gradient descent. So if you see our implementation, let us say you have some 100 data points. So then for our model, like what we can do is, let us say these are the X, this is Y. Okay. So for this, what we try to do, this is true with like every, like both classification and regression. So I can talk about it here. So if you take X and Y, so what we do, like, let me recollect this. So we send our data and we also see what is the prediction, and we compare these predictions, send data, we get out predicted Y predicted. Okay, and we do a comparison between Y predicted and Y actual, and with this we get a loss, and with this loss what we do is we update theta. So after updating theta, means like updating model, and again this process continues, right? So we send the data and then we get the prediction. From that prediction we do the comparison with the actual, we get the loss, we with this loss we do a gradient descent and then update the theta. After updating data, this is what continues, right? So did you get a doubt, like should we send one data point at a time or all data points at a time? So we actually implemented the vector-based implementation where we are able to send like all data points at a time, right? So actually let me show you this. So in case they let me do see all types of scenarios, what will happen. Okay, so we can also send a single data point at a time. Okay, so model, so in case if it is there are data 100, so what happens is data point 1 and you get Y for that, you do the same prediction, loss, this will continue, and then you send data 2, you update parameter, then get data. Similarly, data 3. So each data point at a time. This is one scenario. One data point at once. Okay. Or you can send all data points at once. Okay. So in this case, what we do, if you have 100 examples, okay. So what you do is you send all the 100 at a time and calculate what is the prediction, and from prediction you calculate loss, you send data and update. By this time, actually, if you send all the data at a time, so it's over, right? So we get a vectorized value for it, and then you calculate the loss and then theta. This we have implemented it. Okay, so this we have implemented it before. So this can be a scenario, or sending one point can also be a scenario. Okay, so this is a case. So but if you see, like in our data, like in practical scenarios, we will have data points of maybe some lakhs kind of rows. Okay, so this can be a scenario where it is like, now I wrote it 1 crore, but I have seen like more than that as well. So in such kind of scenario, if you go with this, what will happen? Let's see both. So if you take this, if you are sending one data at a time, data 1 point, first point, and you are going through the model, you got a prediction, you got a gradient, you calculate the loss, you update the theta accordingly, and then you send back to the model. So, and then now you send theta to like data 2, data 3, data points, so on. You should send till these many values, so that you actually were able to complete one complete epoch. Okay, so what we call is, there is a kind of naming convention. What we call is one epoch. So what we call is, there is this kind of convention, if you could remember. One epoch means all data points are trained. Okay, once, and one iteration is one computation of loss function. So think it is like this. So epoch means like actually once you complete all data points like for training, you call it as like one epoch. Okay. So if you do that, actually what happens? So most of the cases, so in case you sent a data point one, okay, let's come back to this. So you calculate like you sent a data one and you calculated and data two calculate, but you have like 1 crore rows. Okay. So this actually takes very lot of time. So even just for one single epoch of like complete data, it takes like lot of time. So this is actually not recommendable. Okay. So what we can go is like we can go to like let's see the alternative other case where we send all the data at once. So okay, what this says is like this has a drawback, very high runtime. Okay, or training time. Let's call it like training time will be very high. The time it takes for training a model would be very high. Okay, but if you take this, what happens is this is a kind of advantage which we have discussed before. So all the like 1 crore data points what we are seeing, right? So all the data points we send together, we get the model, and then we do this, right? This is what we have discussed, if you remember. So in this case, what it like all data we are sending once like as a kind of a using the vectorization concept, right? It can do the computation parallelly at once. So by this, it is just like it will take almost same time as like how it takes for one single data point. Like maybe it takes like for 2 3 data points, like how much it takes, but it will be done very fast. So in such kind of scenarios, very low very low train time, right? So this is not recommended. This is recommended. So, but if you can think of this scenario, what we are doing is we are sending this 1 crore data points at a time. Okay, and inside there will be computation of these 1 crore data points. Okay, so our system should have that capability to handle such kind of big data, such data at once, like such kind of computation. Because for each data point, it should actually calculate all these things. If you remember, if it is for a logic regression, it should do all these computations, right? So all these it should be able to do and give a prediction. So is it possible, like if you send like 1 crore data points, again it will be again system dependent if that machine is able to handle or not. Okay, so this is not implementable in all cases, right? So needs very high computational capability. So the RAM and GPU should be like very high for doing this kind of scenario. Okay, this doesn't require that, right? In case it's not needs. Low computation requirement. So requirement is very low. Like it's not that it needs like very high computational capacity. Very low would be like small would be enough. Like smaller machine would be enough. So this is a kind of comparison. But if you see, both has one drawback and one this thing, right? So which one to use? Like that can be a question. So what we do is like we don't use like both of these. What we go for is something in middle of these two. Okay. So can someone guess like what can be scenario, what we can use, some kind of solution which can actually take best of both worlds. Hello. So one of you, can you guess like if what can be done? Can we should we send like one data at a time or like all data points at a time? So we have seen like some kind of issue with both of them. So hello. So can anyone?
Maybe groups of data.
Yes, exactly. So what we do is instead of sending like this, what we can do is we can take best of these two. Okay, so if we send all, like the computational power is not sufficient. We send one, like training time is high. So what we do is we take best of both worlds where we send those data in batches. Okay, so batch wise gradient descent, I guess. I don't exactly remember the word. So what it will be done learn is like let us say you have this 1 crore data points. Okay, so you have this 1 crore data points. You divide it into few batches. Let us say your RAM is like high. In case your RAM is high, you can go for a higher batch. But if it is a low RAM, so what I do is I make it like 10,000 at a time. Okay, first 10,000 and next 10,000 like this. I am actually splitting into many batches. Okay, so first 10,000 in one batch, second 10,000 in one more batch, third 10,000 in one more batch, like this. Okay, so maybe even this case, like you have like so many batches, but even realistic example won't even be like 10,000. It will be usually, it depends on your data. It's like larger images or like some kind of data, then you will go for like 32 batches, 64 batches. In that case, like I also had a scenario where I have to limit my batch size to 4 or 8 depending on the kind of competition capability it had. Okay, so what we do is we split them into batches. Sorry, just split the data into several batches. Okay, so we have done it. Then we have data. Okay, that we have what we have done. We have split into several batches. Batch one, batch two, so on. Batch 100, let us say. So this is what we have split it into. So once we have done this, what we do is each batch will send once. We do them, take the model, and then what we do is we do a prediction, get loss by and then update theta and then do this way, then send the next one. Then after that, like after this is done, then you send the list. Okay, so once all your data points are complete, right, you call it epoch. So one epoch is done, like one set of entire data has been used for training, so then one epoch is done. So let me define it clearly here. One set of entire data is used for training implies one epoch completed. Okay, so and the second case is like this is epoch, right? But one cycle, one cycle, let's say call it cycle instead of cycle. One cycle of model training is done implies one iteration is done. So here, if you can see in this batch-wise gradient descent, like number of iterations for one epoch, it means let us say there are 100 batches here. Okay, so it do this 100 times it will iterate and update the parameters here, right? So here what will happen is, if you see, let me write all the three here. Okay, batch wise. So all data at once, and then one data point at once. So these are the three what we are discussing right now. So let me go with this. So in this case, what is happening is, so iterations, let's call it epoch. So epoch is equal to number of batches, iterations. So the epoch like needs like there are 100 batches, okay? So it needs 100 iterations to complete one epoch, okay? So this is like, but if you take this case, number of epoch is one, right? Because your entire data is going at once, okay? So for one epoch, it needs only one iteration. So if you take one data point at once, what happens is, so first data point, one iteration, second data point, one more second iteration, third, fourth, so on. If there are crore data points, it will do 1 crore iterations. So number of data points, iteration. So this is what we have. So like there are names for each of them. Like we don't call it like batch wise, all data at once and all. So that name, what we call it is like they have given is, let me take that name here. So we call it this one batch wise as batch wise gradient descent. So all data at once. Uh, uh, what we do is like we call it like batch wise gradient descent, or we can also call it like mini batch gradient descent, right? So similarly, if it is like all data at once, we like let's talk about this like one data point at once. One data point at once, we call it like stochastic gradient descent. Okay, and all data at once is what we can say is like this is a gradient descent, right? So this will come under mini batch gradient descent. Actually, there is no difference between batch wise and mini batch, right? Like it's not batch wise, it's just batch gradient descent, it seems. So and mini batch gradient descent. So mini batch gradient descent is something like your batch size value is one. Sorry, not batch size, number of batches is one. Number of batches is one. Here you can also say this one is also mini batch, saying that one data point at a time, right? Here batch size is one. So each, so some kind of analogy we can do like this, right? Because batch, like if you are dividing into batches, if you keep only one data point in one batch, that's like this, right? Stochastic gradient descent. Your batch size is one, right? So let's not compare it with these two. So this we call it like mini batch as well. We can take that as an example. So there is not much different. I'm not sure why it is called like mini batch, because both can be can give a same sense. So, but why actually these three? Like which one to be taken? Anyway, we discussed one point that like actually what is it like the kind of computational capability and the time consumed. Like these two are the factors which we finally taken this batch wise as a example, like which we preferred. This would give better kind of experience. But in case if you have what you say, like if you have a kind of computational capability where you can uh, like calculate all data at once, you can always prefer this. Okay, but usually that won't be a scenario. Okay, so why actually I should prefer this? So there is something like the accuracy metrics, the performance of your model will actually vary for these. It won't be same, like it won't be same as this. So your accuracy or like other performance will actually be better when you send all data points at a time, but it will be a kind of what it will be done is like let me take this thing. So if you send all data points at once, like your accuracy will be very high. But this is not possible, so we are making it into lower batch, splitting it into batch sizes. But still, your accuracy will be good. But if you send like one data point at a time, your accuracy will be slightly low comparatively. So one more thing, what we can also do is if we can increase the batch size, batch. Wow, what am I writing here? So just so if you can increase your batch size, your accuracy will increase. Let me increases, accuracy increases. Okay, so this is one thing like we it should also see. So mostly that's why in case if it is possible, you can go with this all data at once, or else like we can go with like batch wise. Okay, mostly no one uses this stochastic gradient descent. So why actually this is like, can we come to our generic analogy, like why what is the general sense behind this is if you see all different kinds of data at once and update yourself, then you'll be able to learn like more. Okay, you see only one thing and it's like you show one you read one question and write a test, and read the second question and write a test. So these learn one new thing and write a test immediately, so you won't actually grasp much. So, but if you learn like so many things and then finally from that you write a test, so that actually would be much better. Okay, but the best of these two words is something like this, where you have this batch wise, where because like you can't learn like a whole entire textbook and write a test. So that's why something like the unit test, like quarterly, half yearly, and those. So it's like a kind of batch. You learn like for 2 months, then write one test, and learn like 2 more months, like some more things, then write a test. That's how it is done, right? So it is also similar here. What we do is like we take some data, learn something, and then validate it, and some more data, do some prediction, validate it, and that is how like it is done, and update yourself. So that is what is done in batch wise. Here there is a slightly like small mistake in like what I have told yesterday. So if you remember, like if you send one data once at a time, so that is called stochastic descent, gradient descent. That is fine. But these two are like I have told it in reverse. So actually, if you send all data at once, that is called like batch gradient descent. And if you send smaller batches, in the sense like if you send your data in like few batches, it is called like mini batch gradient descent. This is a difference, like small correction need to be taken. So other than that, rest term is fine. Like this is batch gradient like okay. So if you send it like data batch wise, like we call it like mini batch gradient descent. If you send all data at once, it means like we call it like batch gradient descent. And if it is one data point at once, we call it like stochastic gradient descent. Okay.